So this one problem I had not done that day on Sunday, so maybe we'll do this one here. Suppose there is a pure silicon crystal which has 5 into 10 raised to 28 atoms per meter cube. Okay, so it's a pure silicon crystal. It is doped by 1 part per million concentration of pentavalent impurity. So we are going to add a pentavalent impurity. So 1 part per million. That means for 10 raised to million is 10 raised to 6. For 10 raised to 6 atoms, I will be adding 1 donor impurity. Isn't it? 1 donor I'll do. 1 part per million. इतना ऐड करूंगा. So calculate the number of electrons and holes. So we have to calculate how many electrons are there and how many holes are there. Given that the intrinsic concentration means the concentration of electrons and holes which are equal for an intrinsic semiconductor. That is this value. 1.5 into 10 raised to 6 per meter cube. Okay, so we have to first find out how much is Ne, and then we can find out NH by using the formula Ne into NH, we know is going to be Ni square. In an extrinsic semiconductor, this product is not going to change. That's going to remain constant. It's going to be Ni square. तो intrinsic में हम लोग लिखते हैं Ni equal to Ne equal to NH. So here also the product of Ne and NH is going to be Ni square only. And even in extrinsic, electrons ज्यादा होते हैं, holes कम होते हैं, या holes ज्यादा होते हैं या electrons कम होते हैं. Any one of it could happen, but finally the product is going to remain same only, na? That's not going to change. So we have written this for extrinsic semiconductor, but it's valid also for intrinsic also. So extrinsic semiconductor के लिए ये value है. Okay, so see, one donor impurity you're adding for so many atoms. So how many atoms you're having basically? So we have to now find out how many donor atoms you've added. So you can say the total atoms आपके पास है 5 into 10 raised to 28 atoms. So can't I calculate ND? So I can say ND is going to be 5 into 10 raised to 28 divided by 10 raised to 6. That is 5 into 10 raised to 22. इतने donor atoms आपने add किए हैं. Now how much is going to be the number of electrons then? Can you tell the answer now? You know the number of donor atoms, so can you tell me how many free electrons are there now? Every donor atom will give how many free electrons? In pentavalent impurity में हाँ एक, क्योंकि 4 इलेक्ट्रॉन कोवेलेंट बॉन्ड्स फॉर्म करेंगे 4 सिलिकॉन एटम्स के साथ, और एक बचेगा जो डोनर लेवल पे रहता है, और डोनर लेवल से वो कंडक्शन बैंड चला जाएगा विद एनर्जी if it gets an energy of 0.01 electron volt. So Ne is equal to Nd only, because हर एक एटम से एक इलेक्ट्रॉन मिलेगा. तो 5 into 10 raised to 22 फ्री इलेक्ट्रॉन है आपके पास. तो ये पहला डेटा मिल गया. अभी दूसरा वैल्यू आप यहां से निकाल सकते हैं NH का. So NH equal to this one, I think this is 2.25 into 10 raised to 32 divided by this value 5 into 10 raised to 22. Okay, so we can calculate this 0. Or I can say 4.5 into 10 raised to 9 holes. बराबर 4.5 into 10 raised to 9 holes. So there are problems in this chapter. Okay, so हम लोग अभी क्या करने वाले हैं ना, पहला ये जो थियोरी पार्ट है, जैसे टेक्स्ट बुक को चाहिए उतना हम लोग करेंगे पहला. और उसके बाद once the Diwali is over, then we will go back to the chapter of wave motion, I think ना, I think waves हम लोग कौन सा पढ़ा रहे थे हम, SHM, हाँ, SHM के जो प्रॉब्लम्स है, एडवांस प्रॉब्लम्स, वो हमको करना है। और उसके बाद कौन सा टॉपिक था उसके बाद, वो इसका था, वेव्स का था, इसका बाकी है। फिर मॉडर्न फिजिक्स का जो एडवांस प्रॉब्लम्स है वो देखेंगे हम, और सेमीकंडक्टर्स। ये चार चीज हम लोग करने वाले। इसका हाफ हो गया है हमारा, हम लोग कर रहे थे, इसका आधा हो चुका है, थोड़ा सा बाकी है इसका। And Sharvari will always say rotational motion. I know that. Even before seeing the chat box, I knew that. That is rotational motion only for collision type of thing in rotational motion. Okay. So NEET में भी काफी problems है इस section में. There is a lot of theory part also. और JEE mains में भी काफी problems आते हैं semiconductor section में, तो वो सभी हम देखेंगे बाद में। चलो यहां से आगे जाते हुए हम लोग को सीखना है व्हाट इज पीएन जंक्शन, बिकॉज पीएन जंक्शन इज वन ऑफ द बेसिक ब्लॉक्स ऑफ एनी सेमीकंडक्टर डिवाइस। अगर आप ट्रांजिस्टर लेंगे या जेफेट लेंगे या मॉसफेट लेंगे, दीज आर ऑल सेमीकंडक्टर डिवाइसेस, या डायोड्स लेंगे, ये सबके जो बेसिक बिल्डिंग ब्लॉक है ये पीएन जंक्शन है। तो हमने पी सेपरेटली पढ़ा, एन सेपरेटली पढ़ा, अभी हम दोनों को कंबाइन करेंगे तो पीएन जंक्शन डायोड फॉर्म होता है। तो इसके बारे में थोड़ा सा देख लेते हैं। तो ओके, सो दिस PN junction formation, I think this was where I was there for the CBSE part. Mohit, ये वाला पार्ट किया नहीं था ना मैंने on Sundays जो मैं ले रहा था आपका? I had stopped it with the last problem. I think last problem किया नहीं था. I think this was where we had stopped up. So we will continue from there. Yesterday we could not meet. Okay, तो PN junction में क्या करते हैं कि एक P और एक N को साथ में लेके आते हैं। अभी साथ में लेके आने का मतलब ये नहीं कि हम उसको आके चिपका देते हैं, इट्स नॉट लाइक दैट। देयर इज अ सर्टेन वे टू फॉर्म अ पीएन जंक्शन, एंड दिस टाइप ऑफ पीएन जंक्शन फॉर्मेशन, हाउ इट इज डन, इज अ सब्जेक्ट मैटर ऑफ इलेक्ट्रॉनिक्स इंजीनियरिंग में आप लोग सीखेंगे ये कैसे इसको आप फ्यूज करते हैं। हमारा कॉन्सेंट्रेशन अभी यहाँ पे वो कैसे फ्यूज करते हैं उसके ऊपर नहीं है, हम इतना ही देखते हैं कि एक पी और एन रीजन अगर हम साथ में लेके आएंगे तो व्हाट आर द डिफरेंट थिंग्स व्हिच विल हैपन। तो आपको पता है कि पी रीजन में जो कॉन्सेंट्रेशन ऑफ होल्स है वो ज्यादा है कंपेयर टू द कॉन्सेंट्रेशन ऑफ इलेक्ट्रॉन्स, और एन साइड में जो कॉन्सेंट्रेशन ऑफ इलेक्ट्रॉन्स है ये कॉन्सेंट्रेशन ऑफ होल से ज्यादा है। अभी इसका मतलब है दैट यू आर हैविंग अ टिपिकल सिनेरियो ऑफ अ कॉन्सेंट्रेशन ग्रेडियंट। So just like gas molecules में होता है कि if there is more gas molecules on in one side of the room as compared to the others, then we have studied that there is a diffusion of gas molecules from higher concentration to lower concentration, and the same thing happens here in a PN semiconductor. When you join the P and N regions by certain fabrication techniques, then the concentration of holes being greater on the left hand side will diffuse from the P to the N side, and similarly the electrons which are greater in number on the N side will diffuse towards the P side. Okay, and this is basically going to contribute to a current called as the diffusion current. Okay, diffusion current, because it is basically movement of electrons and movement of holes. So when electrons move or holes move, it's going to form current. So that's why we are saying diffusion current is formed here. Correct? So we have just written all those things here. यहाँ पे लिखा हुआ है something like this. ये आपका concentration ज्यादा है होल्स का and यहाँ पे concentration कम है तो diffusion होगा. Same thing आप इलेक्ट्रॉन के लिए भी दिखा सकते हैं. जहां पे इलेक्ट्रॉन का concentration ज्यादा होगा, there will be a diffusion towards the lower concentration side. So now what's going to happen is that if I draw the PN junction here, what is the comment? Show the previous slide. कौन सा slide है? ये वाला. ओके, सो ये आपका P और ये आपका N साइड है। ओके, नाउ एक चीज आप बोलो कि N साइड में आपको याद रहेगा पेंटावैलेंट इंप्यूरिटीज होता है। तो जो डोनर एटम है, डोनर एटम एक इलेक्ट्रॉन देता है और इलेक्ट्रॉन देने के बाद वो आयनाइज हो गया। कौन सा आयन है, पॉजिटिव या नेगेटिव आयन? एन रीजन में आपके जो डोनर एटम्स है ये पॉजिटिव आयन होंगे कि नेगेटिव आयंस रहेंगे? आफ्टर यू गिव एन इलेक्ट्रॉन, 5 इलेक्ट्रॉन्स थे ना, तो उसमें से एक दे दिया उसने, तो एक दिया तो एक डिफिशियंसी हो गया इलेक्ट्रॉन का, डिफिशियंसी हो गया यानी पॉजिटिव आयन है, नॉट नेगेटिव, पॉजिटिव आयन। इलेक्ट्रॉन दिया है, उसके पास 5 थे वैलेंस, उसमें से एक दे दिया तो एक डिफिशियंसी इलेक्ट्रॉन का, तो ये पॉजिटिव आयंस है। ओके, तो पॉजिटिव आयंस तो है यहां पे, और उसके साथ आपके फ्री इलेक्ट्रॉन्स भी है। और यहां पे इस रीजन में तो डोनर एटम, ये मैं कहूंगा ये इलेक्ट्रॉन दे रहा है और ये बन जाता है पॉजिटिव आयन। जो इमोबाइल रहता है वो मूव नहीं कर सकता क्योंकि आयन तो हेवी होता है। एंड सिमिलरली योर ट्राइवैलेंट इंप्यूरिटी जो है, दैट्स गोइंग टू बी एन एक्सेप्टर एटम, इजंट इट? एंड एक्सेप्टर एटम आपका क्या होता है, नेगेटिव आयन, नेगेटिव आयन रहेगा बिकॉज इट इज गोइंग टू एक्सेप्ट एन इलेक्ट्रॉन। ये डोनेट करता है इलेक्ट्रॉन और ये एक्सेप्ट करता है इलेक्ट्रॉन, तो एक्सेप्ट करने के बाद नेगेटिव आयन फॉर्म होगा। इज दैट ऑल राइट? नाउ व्हेन द होल्स गो from the P region to the N region, what's going to happen is that all these negative ions are going to be uncovered. What do you mean by uncovered? Can anyone tell what do you mean by uncovered? इमोबाइल जो आयंस है वो अनकवर्ड हो जाएंगे। अनकवर्ड का मतलब है प्रीवियस टू द डिफ्यूजन प्रोसेस देयर वाज इलेक्ट्रिकल न्यूट्रलिटी because the total number of positive charges was equal to that of negative charges on both N side and P side. But after the diffusion processes happen, N region में इलेक्ट्रॉन चले जाएंगे P region में। So now for those positive ions, you don't have a compensating free electron available. And that is why these ions are called as uncompensated. Uncompensated. या इसको कभी भी हम लोग अनकवर्ड भी बोलते हैं, अनकवर्ड आयंस। इसका मतलब है कि जो करस्पॉन्डिंग इलेक्ट्रॉन था या which was maintaining the neutrality, that is no longer there, that has already got diffused on the other side. And now this particular region which you can see here is what is going to be depleted of all the charge carriers, क्योंकि ये जो होल्स है और जो इलेक्ट्रॉन्स है इस रीजन में वो तो एक दूसरे के साइड में जा रहे हैं। So this region is going to be depleted of all charges, and that's why this region we call it as a depletion region. तो डिप्लीशन रीजन का मतलब है डिप्लीटेड ऑफ चार्ज कैरियर्स। ऑल राइट, कैन वी गो अहेड? एनी डाउट इन दिस पार्ट हियर? ये थोड़ा थियोरेटिकल पार्ट है, तो देयर इज अ लॉट ऑफ थ्योरी टू बी एक्सप्लेन्ड इन दिस चैप्टर। Okay, so as long as you don't comment anything, I'll just keep going ahead. So similarly, we say that hole diffuses from the P to N junction, and it is going to leave behind an ionized acceptor, which is immobile. जो भी मैं बोल, whatever I've spoken, it's all in written format here. And similarly, as the holes continue to diffuse, there is going to be a layer of negative charge, which is going to be left on the P side, which I had shown here. The layer of the negative charges, which is going to be left out here. Okay, so same thing I've explained here. Then this space region on either side is what is called as a depletion region, because the electrons and holes that were taking part, which were there in the N region and P region, they are completely depleted of the free charges. And typically the thickness of this depletion region is of the order of 1/10 of a micrometer. Okay, 1/10 of a micrometer. It's not a very large distance. It's a very small distance over which the depletion region is there. Why does the depletion region not proceed further and occupy the entire P and N regions? Why does it limit itself to 1 micrometer? Harsh, can you tell the reason for that? Here we have shown that the depletion region is only so much, 1 micrometer. Why doesn't the holes here and the electrons here completely diffuse, and complete depletion region क्यों नहीं form हो सकता? What is the reason for that? Because the moment this depletion region is going to be formed, you're going to have an electric field directed from this side to this side, left to right. There is a electric field, because यहाँ पे positive charge है, यहाँ पे negative charge है, so there's going to be an electric field. So when this electric field is going to be, no, not repulsion or attraction, ये जो electric field जो generate होगा, जो holes रहेंगे यहाँ पे, can holes move in the direction opposite to the direction of electric field? Is it possible? And similarly, what about the electrons here? Can electrons move in the direction of electric field? Is it possible for it? Electrons move in the direction opposite to the electric field, and holes move in the direction of the electric field. So neither the holes nor the electrons can now cross the region, the depletion region. So when sufficient depletion region or electric field is generated, it stops the further diffusion process, and therefore the diffusion current becomes zero. All right. Actually zero नहीं होता, zero यानी the diffusion current decreases. यानी initially when you join the P and N region, diffusion current is maximum, and once the depletion region is formed, the diffusion which is happening greatly reduces, because there are always going to be some holes and some electrons with higher energy level which can always cross the depletion region, though small in number. There will always be some holes and electrons like that. So it's not that diffusion current becomes zero once the depletion region is formed. Diffusion current will still exist even after the depletion region is small, but it will reduce. That is for sure. All right. So I hope it's clear that why the depletion region process does not occupy the entire P and N junctions. I hope that part is clear. Now, what I was saying here, the thickness is 1/10 of a micrometer. The reason for that we have said here. So we are writing here what we had explained, that due to the positive charge region on the N side, okay, so positive charge on the N side, and due to the negative space region on the P side, an electric field is generated, in this particular direction, like this. And due to this, an electron on the P side. Now see, यहाँ पे दूसरा चीज बात कर रहे हैं. So there are two types of currents. One is the diffusion current, and what is the other type of current which is there in semiconductors? Diffusion current is due to which type of carriers? Majority carriers or minority carriers? Can you answer that question, anyone? Diffusion current is due to majority carriers or minority carriers? We'll just continue for 2-3 minutes and then wind up. Majority, yeah, majority here, because holes diffuse and electrons diffuse. It is because of majority carriers. And there is another type of current which can be formed in PN junction diodes, which will not be hindered by the electric field. Which are those carriers? See, in the P region, there is always going to be thermal generation of electron hole pairs. That is not going to stop, thermal generation. The electron hole pairs are going to be continuously formed, though small in number, it is there. So in the P region, you're going to have some electrons also. which are called as the minority carriers here. And similarly, in the N region, you're going to have holes, which are the minority carriers in this region. So this electric field is actually going to aid those electrons on the p side to get accelerated opposite to the direction of electric field. Similarly, it will aid these holes to move on this side. So there are going to be charges which are going to cross the depletion region even after the depletion region is formed. And the current due to this motion of minority carriers is called as the drift current. And the drift current is always opposite to the diffusion current. So when you're having a PN junction diode, which is kept inside your cupboard, which is behind me, it's a cupboard. So we keep it inside the cupboard, which is not connected to any voltage source. The diffusion current is equal to the drift current at equilibrium. And therefore the net current flowing in such a PN junction diode, which is kept inside the cupboard, is zero. Okay, so only when you forward bias it, or if you reverse bias it by applying some voltage, will you get some net current flowing in such a junction diode. Is that concept clear, Mohit? Actually, Mohit, Shreya, इन लोग का ज़्यादा important है, because ये बाकी सब तो पढ़ा चुका हूँ बाकी लोगों को. Even others might be already knowing all this. Is it clear, Mohit? Diffusion current and drift current concept. Okay, so I think that Mohit has got very tired. So I think we should stop here, and on Wednesday we'll continue with this. So I think how many slides we have before we start off? ये जो पार्ट है, इतना पार्ट आपने लास्ट सेमेस्टर में ये सब पढ़ाया है, बट ये वाला पार्ट रिवाइज करना भी बहुत इंपॉर्टेंट है, नहीं तो यू विल नॉट गेट द लिंक ऑफ दिस. तो इतना पार्ट मुझे करना है, और इसके बाद आपका यहां से शुरू होगा 11th में 12th का पार्ट, application of diode as a rectifier. I don't know how many of you all basically you're not comfortable with these values, like you can tell me, because then unnecessarily I don't have to do this part. I can do it only for CBSE students. ये सब पार्ट आपको पता है क्या? ये सब थ्रेशोल्ड वोल्टेज 0.2 वोल्ट होता है, जर्मेनियम का, सिलिकॉन का होता है. Why there is threshold voltage? Why threshold voltage of germanium is less than silicon? Okay, why the current is constant in this particular region? यहाँ पे constant क्यों है? यहाँ पे suddenly increase क्यों होता है? ये सब चीज आपने पढ़ा है क्या 11th में ठीक तरह से? VI characteristic of a PN junction diode. Maybe the HSC students can answer this so that I get some clarity on this part. Or do you feel that it is important to quickly revise this part before I go ahead? Need a revision, okay. ठीक है, तो maybe half an hour we'll spend on this initial part, and remaining 2.5 hours we'll continue with that. ठीक है, चलो. So we'll stop here, and I think Wednesday and then next Monday. So in these two classes we'll try to finish off the semiconductor devices, so that that one small topic of polarization we can do on next Wednesday after that. So we'll end up today.